This is the low-level video on linked lists for advanced comp sci. So for this video I'm using the assignment double linked lists, which creates given a double linked list class, you're tasked, or DL node, you're tasked with creating a double linked list which adds elements such as adding, inserting to the list, getting an element, and removing an element. So in this method, we were tasked with creating a few methods. First one was the add method. The add method kind of shows some of the unique characteristics of linked lists and double linked lists in particular. One of them is that you have to have a dynamic allocator to determine the size. For an array, you don't need to store the size, say, because the size is created when you create the array. So if you say create an array of size 8, you can be confident that that array will always have 8 elements. They may just be zeroed out, but you will always have 8 elements, no more, no less. But when a DL node or DL list is created, you don't know. So you need to have a dynamic variable, like over here, you have size. We need to keep track of that, and every time we add an element, we have to manually increment size. So in order to add, first we check that we have special cases for adding to the first and adding to the last. Because in a linked list, this means that there are special things that have to happen. Versus if you just add it into the middle of the list, there's a different work process. So the first thing we do is we create a temp node. I just called it over here. I'll just call it TMP. And I set that value to the value of opt, which is what you want the value of that to be initialized to. And then we do this sort of for loop over here. And it's kind of it's a bit different from a normal for loop that we're a bit used to, because instead of having an incrementer at the end, starting off with an initialization of a variable, and then having a condition in the middle, kind of flips it on its head. So it starts off normal, so you're initializing the variable I, but then you're doing I++ is less an index. So you're both incrementing and checking the condition in just the condition part. And then in the next part, we do ind equals ind.getNext. What this is going to do is going to increment I, and it's going to check that it's less than the index, and for each time it's doing that, the index will go to the next index. And this will occur until I is at the point where it is equal to the index, at which point the condition will fail, and instead of having any conditions, just a semicolon, it'll go on to tmp.setNext. So now that it has the correct index, it now sets the tmp variable. It sets the next variable of that to be ind, which means that it'll just go to the element that you just created, and then it'll set the previous as the previous of the ind, and then it'll change the values of ind and tmp in order to link them together so that they're seamlessly placed into the list. And then another one, of course, for get, we're using that same for loop, and then we're just using the tmp.getValue function in order to get the value of that element. Set is the same thing, pretty much, but you're just storing the value that was previously there. And then remove is sort of the next sort of interesting one, because you're doing tmp equals head, right? And then you do the same for loop, and then instead of creating an element, you're removing an element. So you do tmp.getPrev.setNext to tmp.getNext. That's basically setting the previous node to tmp to skip over the TMP node, and then you get the next node to TMP to skip over as previous node the TMP node. And then it decrements size. Now there's sort of a misconception that if you do this, the element will still exist, which it should, but Java has advanced garbage collecting, so when it sees that there's an element that's not linked to anything, and it's not even linked to a variable, it will automatically destroy that element, which will allow you to allocate the system resources devoted to that node back to other processes. You can run the program a bit faster, so because you have more computer resources to allocate to other aspects of that. And now we can run this, so we just do Q, and then it's Java C dll.java, and that's Java DLL. And now, of course, it's actually the driver method in this one. It's not actually the class, because the class is just defining it. So we can do Java C DLL driver.java, and then Java DLL driver. And it produces the correct output aligned with right here. And this is the exact output that it produced.